Let's talk about glass evidence, what we can analyze from glass, how we use it, and everything in between. So a little bit of introduction and history for you. So analysis of glass at a crime scene can yield trace evidence. So it gives us a trace of what was left behind. So as far as our history is concerned, the earliest human-made glass objects, which were beads, date back to 2500 BC in Egypt. So glass has been being made for a very long time, historically speaking. Specialized glass production was an art, a science, and a state secret in the Republic of Venice over the span of hundreds of years. You may have heard someone talk about Venetian glass as if that glass was very fancy. And that's because Venice is where fancy glass really originated from. And if you were a Venetian who spilled these secrets on how they were making their glass, you were subject to maybe even death as a result of it. So Venice took their glass very seriously. However, they couldn't keep their secrets of glass their own forever. By the 14th century, knowledge of glass production had spread throughout Europe. And then the Industrial Revolution brought the mass production of many different types of glass, which kind of leaves us where we are today. Now, new types of glass are always being developed, but it was really the Industrial Revolution that set off all of these different types being needed and also being made. So what is glass exactly? So once it cools, glass can be polished, ground, or cut for useful or decorative purposes. And glass blowers can form glass into many different shapes, not just flat panes. So we can do a lot of different things with glass. The reason for this is most solids are what we call crystalline solids, which have a regular atomic structure, which you can see right here with the blue and red alternating at every point. This is a crystalline solid. However, glass is an amorphous solid, which you can see here, and it has an irregular atomic structure. It is not all neat and organized. This is why when we break glass, it breaks into a variety of different sized and shaped pieces because it's following these atomic lines. Meanwhile, if glass was a crystalline solid, it would break along these straight lines. But since it's an amorphous solid, it breaks into all these unique pieces. As far as types of glass are concerned, glass is an amorphous solid, like we just talked about, and it's typically made from silica, calcium oxide, and sodium oxide. Because glass is made of a variety of compounds, there are many different types of glass. So we can make glass with different compounds to give it different properties. And we want glass to have different properties depending on what its function is going to be. Car glass is not the same as window glass, for example. So we create different types of glass. We can also add different metal oxides to glass mixtures to produce different colors. That is where stained glass comes from. Stained glass is technically glass that is made with different metal oxides, although in recent times we've started to just paint over clear glass with clear colored paints to make essentially fake stained glass. Now, because we have different types of glass, glass can have different densities and different refractive indexes. And this allows us to compare one type of glass with another and figure out at a crime scene what type of glass we have specifically. So let's talk about those. Up first, we have density. The formula for calculating density, which you're probably familiar with back from chemistry or physics, is D equals M divided by V, in which the M is the mass of the fragment of glass, and we do this using some sort of balancing device. We can place the fragment of glass into a graduated cylinder filled with water to measure the volume, V, of the overflow. And if we divide the mass in grams by the volume in milliliters, we will find the density of the glass fragment. Now, different types of glass have different densities, so by calculating the density of a piece of glass, we can figure out what type of glass it is. Why might we want to do this? Because it's going to help us know whether that piece of glass makes sense at our crime scene or not, and also try and figure out where that piece of glass may have come from. Now, the second characteristic, refractive index, is a little bit more difficult, and it's something that you may have heard about before. So when a beam of light moves from one medium to another, its speed changes. And this change in speed causes the beam to change direction and therefore bend. You are very familiar with this. If you've ever gone underwater and opened your eyes, you know the light looks crazy underwater, and that's because as the light moves from the air to the water, it is causing all of those beams of light to bend. In the illustration that you see on your screen right now, as well as on your notes, the green line, and make sure to color your drawing on your note sheet. The green line to the right of the red line shows the direction of the beam had it not been changed. So green is showing if it had no refractive index, it didn't move it at all. However, the black line is showing that it's being bent towards what is called that normal line, that center line, indicating that whatever substance that light is passing through does have some sort of refractive index. So let's talk a little bit more about refractive index. Refraction is the change in the direction of light as it changes speed when moving from one medium to another. We already talked about that. The direction of light is going to form two angles with the normal. We have the angle of refraction, which is the original beam of light compared to that center normal line. And then we have the angle of incidence, which is the normal compared to how the light has now bent. If the light passes into a denser medium, that gray area, it's going to bend towards the normal versus away from the normal. Now, as far as our calculations are concerned, we are going, in order to calculate the refractive index, the formula is N1, in which N1 is the substance's refractive index. We can calculate the refractive index for a glass or a liquid, and this is what we're trying to solve for. N2 is the refractive index of the air, which we do have to take into account, and the refractive index of air is 1.0003, so that's essentially a constant for us. Technically, that number can change, but for our purposes, it's a constant. Then you do the times the sine of angle 2. Angle 2 is our angle of refraction within the gray area, so after the beam has bent. And angle 1 divided by the sine of angle 1, which is our angle of incidence, the original angle of the light beam towards the normal. And we can do that calculation to calculate the refractive index of anything. Now, sometimes the glass fragments that we find at a crime scene are going to be too small in order to do the laser beam refractive index method that we just learned about, where we pass light through the piece of glass. If the glass is too small, we're not going to be able to get an accurate measurement on that. So there is a second method that we can do that we will be utilizing in class, which is the submersion method that can only provide us estimates. The laser beam method does provide us with a pretty accurate refractive index. The submersion method is going to provide us with an estimate. How this works is we submerge that piece of glass in a liquid and we look for what are called Becky lines, and that is this dark outline that you can see on the piece of glass in the picture. If Becky lines are visible, that means our liquid and our glass have different refractive indexes. So we can keep either using different liquids or heat and cool one liquid, because you can change the refractive index of liquids by heating or cooling them, until no Becky lines are visible, meaning the piece of glass essentially disappears like magic. When no Becky lines are visible, that means the refractive index of the glass and the liquid are the same. So then all we have to do is calculate the refractive index of that liquid, and we know what the refractive index of the glass is. Now, another big thing that's important as far as the forensic analysis of glass is how glass breaks. Many times we have multiple pieces of broken glass or a window that's been broken but is still together at our crime scene. So glass actually stretches slightly when hit. If you watch a slow motion video of glass being broken, you see that the glass stretches before it breaks. And because it's an amorphous solid, like we talked about previously, it's not going to break into regular pieces with straight line fractures. It's going to provide these seemingly random fracture patterns, but to a forensic scientist, they mean something. And we can figure out the direction that the hit came from, the rate that the hits occurred at, as well as the sequence of impacts from looking at a piece of broken glass once we've either reassembled it or if it stayed together. So there are two types of fractures we are concerned with, radial and concentric fractures. So let's talk about both of them. So when we break a piece of glass, the glass is compressed on the impacted side, the side the hit came from. That means it's going to stretch on the opposite side. So it impacts on the side of the hit, stretches away from the hit. And the tension from that stretching is what causes radial fractures to occur because they radiate, hence the name, outward from the point of impact. So these are not straight lines, but they are jagged lines that occur. Meanwhile, on the same side of the impact, you are going to get concentric fractures, which are so named because they form concentric circles on the same side as the impact. Now, it is important to determine what side the impact came from using these radial and concentric fractures because we need to know, did the hit come from inside the house, outside the house? That can be very important to establishing what actually occurred. Now, we can determine what side the force was applied from by looking for what are called conchoidal lines. Now, conchoidal lines, this is as if you were looking at a piece of glass, not so you see through the glass, but from the side of a piece of broken glass. So looking at glass through the thin way. And these are conchoidal lines, these little curves right here. In a radial fracture, so one of those jagged line fractures, you can see that these curves are going towards the side the force is applied from. Meanwhile, on the concentric fractures, you can see that the curves are moving away from the side that the force is applied from. So we can, as long as we know whether it is a radial or concentric fracture, we can look at the conchoidal lines to determine what side the impact came from, which once again is important for determining the story of what happened. We can also determine the order the impacts occurred in if we have more than one impact. And this is actually more simple than you may think. You can determine the order of the hits that occurred in glass because one fracture will stop another fracture, and whichever fracture did the stopping came first. So in this picture on your screen right now, I know with certainty this fracture occurred first, and this one occurred second because we can see the second one is trapped inside the radial fractures of that first hit. So this was our second one, that was our first one. Once again, this can be very important in order to figure out the story of what happened or to confirm a story a witness is telling you of what happened. Now, a not necessarily common, but normal way that glass ends up breaking is due to bullet incidents. So as a bullet passes through glass, it pushes a cone-shaped piece of glass out ahead of it. So we sometimes find these cone-shaped pieces letting us know that we had gun activity. Just like we learned about during ballistics, the exit side is going to be the larger side than the entrance side. So just like wounds, it's the same for glass. Radiating fracture lines from a subsequent shot will stop at the edge of the fracture lines present from the glass. So bullets do not change any of the rules that we've learned about glass, but they are going to push that cone out. Additionally, the entry hole will be rounded if the bullet was perpendicular to the pane, just like we saw in our last unit. And if it's fired from an angle, glass pieces will be forced out in that opposite side from the shot. The angle at which bullets enter window glass can help locate the potential shooter. So just like what we talked about in ballistics, I know we were typically talking about bullet wounds, but the same does apply for glass. Now, a vocabulary term for you is bits of glass can fly backwards when we have gun activity on glass, creating what is called backscatter. So this is essentially because of the force that the bullet is going to go through the window at. Sometimes glass flies backwards at the person who shot the gun. And these little pieces of glass can get stuck on them and can help us prove that that person was in fact at the scene and was likely the person that fired the gun. So backscatter can be very important for us. Now, last but not least, we want to talk about the handling of crime scene glass samples. So first, we're going to identify and photograph any glass samples before moving them. This has always been our standard protocol, but this is your reminder that it is true for glass as well. We're going to collect the fragments that can be reasonably collected. Now, some of you just heard me say collect only the big fragments, which is not what I said. We're going to collect anything that can be reasonably collected. Sometimes glass can end up in a fine powder that is almost impossible to successfully collect. But any piece that we could pick up with forceps, we're collecting those. We want to identify the outside and inside surface of any glass if at all possible. This is particularly true if we have a window that is still partially maintained and we want to take that window with us. We want to mark what was the outside and what was the inside. If multiple panes are involved, we want to make a diagram. We don't just want to have bags of glass evidence and no clue where they came from. If we have multiple broken windows, we want to have kind of diagrams locating each of those. We're also going to want to note trace evidence such as skin, hair, blood, or fibers found on our glass. While glass evidence is very valuable, skin, hair, blood, or fibers could be even more valuable, so we want to make sure that we locate and properly secure that evidence as well. A lot of times people break a window to come through that window and end up cutting themselves or something and leaving more evidence behind. And as always, we're going to package all of our materials collected and maintain that chain of custody because we are allowed to use glass evidence in court, so we want to make sure that we had that chain of custody ready to go. All right, so that's what you need to know about glass. Come to class ready to practice.